All right, welcome to Mr. Baker's House Knowledge. Today we're going to pick up the other two ways to make the other 2 points of concurrency. We need to be working with something called a median. A median is a line in a triangle that connects one of the corners of the triangle, the vertex, to a midpoint. So vertex to midpoint, corner to middle of side, that is called a median. When you have medians that intersect, they will be concurrent at a point known as the centroid. So median connects you to the centroid. Now, the centroid is really interesting. There's something really, really cool about the centroid. The centroid's location in the triangle is 2/3 of the way away from the vertex and 1/3 away from the line of the distance of the median. So it divides the median in a 1-to-2 ratio. The 2 part of the ratio will be the longer segment from the point of concurrency to the vertex. The 1/3 part is going to be the shorter segment from the point of concurrency to the side. So once again, the longer segment, the 2/3 segment, is from the point of concurrency to the vertex. The shorter segment is from the point of concurrency to the side. That's what a centroid does. So let's take a look and see calculation-wise how that works out. So how can we identify point C? What's point C? It is a centroid. C is a centroid. The reason it's a centroid is because it's the point of concurrency between 3 medians. AB is a median, EG is a median, and DF is a median. A median is identified by connecting a vertex to a midpoint. So since C is the centroid is going to be a 1/3, 2/3 distance of this whole line. All right, so for example, if I tell you that FD is equal to 30, then I know that FC is going to equal 1/3 of that, and I know that CD is going to equal 2/3 of that. So what's 1/3 of 30? 1/3 of 30 is 10, so this length is 10. What's 2/3 of 30? 20. So this segment is 20. What does it appear the relationship between this segment and this segment is? Yep, the longer one is twice as long as the shorter one. That makes sense since they're in a 1-to-2 ratio. This one would be 2 times as much as this one. So hopefully by knowing this information, no matter what part of the segment I give you or what segment I give you, you can find the parts. For example, what if I told you that AC was 10? How long do you think CB would be? 5. Because 5 is half of 10, right? And how long do you think AB would be? 15. Because by the segment addition postulate, you can add these 2 segments together and get the whole long line. All right, so here's what we're going to practice. I'm going to give you a length, and what I want you to do is, and I'm going to ask for 2 other lengths, and so we're basically going to play fill in the blank. Are we ready? All right. So FD is equal to 81. I want you to find FC, and I want you to find CD. Ready, go. All right, hopefully you were ready to realize that the shorter segment is going to be 1/3 of the whole thing. So if I take 81 and I divide it by 3, I get 27. So the value of FC is 27. if I take CD and divide it, multiply it by 2/3, or even easier, if I just double the 27, then I find out that CD is 54. Is everybody okay with that? All right. So let's do another one. I'm going to tell you that AC is 11, and you need to tell me BC, and you need to tell me AB. So hopefully you realize that AC was the longer length. It's 2/3 the length. This is 1/3. That means AC is going to be twice as long as BC. So I could represent BC as 11 divided by 2. Or 11 halves. Or you could do 5.5. So AB is going to be 11 halves plus 11. That's 11 halves plus 22 halves, which is 33 halves. Or if you wanted to, you could say 16.5. Any questions about how I found those values?
Why wouldn't it be,
yeah, I don't understand that. Why you couldn't just like multiply 11 times 1/3?
Because 11 times 1/3 is 1/3 as much as 11. If I divide something in a 1/3 portion and a 2/3 portion, comparing the two portions, 2/3 is twice as much as 1/3. It's 2/3 of the whole line, but twice as much as the leftover. So if I divide a line in 2/3, and each third is 5 units long, this is not 10 times 1/3 to get that other one. This is 2/3, so 2/3 is twice as much as 1/3. 10 is twice as much as 5. But 2/3 of 15 is 10. 1, 2. 2/3. 5 plus 5 is 10. 1/3 of 15 is 5. And the 2/3 is twice as much as the 1/3. Does that make sense?
so
Yes,
you're
ma'am.
saying don't do it on the calculator.
I wouldn't.
So say like BC was 11, would that make AC 22 and AB 33?
All right. So yes, if BC is 11, then this line is half the length of this line. So this line would be 22. I would double the 11 to get the 22. Then the whole thing is going to be 33. All right, let's do another one. EG equals 20. Find EC and CG. All right, hopefully you realize that EG was the length of the whole thing, and so CG is 1/3 of EG. So CG is 20/3. If I double, 20/3, if I double 20/3, that's doubling the top number, 40/3. 40/3 plus 20/3 adds together to be 60/3, which is the same thing as 20. All right, so you should be in pretty good shape to finding the values of lines that are located, medians that are located through a centroid. The other thing we're going to pick up is the altitude of a triangle. You've actually probably worked with altitudes of triangles on many, many occasions. That's the height of the triangle. An altitude goes from the endpoint or corner or vertex of a triangle perpendicular to the opposite side. It's how tall the triangle is if you use the side as a base. The point of concurrency for altitudes is an orthocenter. To sum up, we have 4 points of concurrency: circumcenter, incenter, centroid, and orthocenter. And respectively, they match with perpendicular bisectors, angle bisectors, medians, and altitudes. So we're going to have to identify which line we're looking at in a triangle And if we have more than one of them and then they cross, we're going to have to be able to tell what point of concurrency we're at. That's the skill set that we need to obtain by the quiz on Thursday. So let's take a look at a picture. Okay? If this is A, and this is B, and this is C, and this is D, and this is E, and this is F, and this is G, and this is O, then can we identify B, G, D, F, and C, E as to what type of lines they are? And is O a point of concurrency? And if so, which one is it? Well, I'm going to give you a little bit of a hint. So we've talked about perpendicular bisectors. We've talked about angle bisectors. We have talked about medians. And we have talked about altitudes. There are some key components that each one of them has. A perpendicular bisector has a right angle and a midpoint. So I guess I could say here, AG is equal to GE. And I have identified point G as a midpoint. So this is a midpoint, this line touches a midpoint, and it's a right angle. What do you think it is? That's right. So BG is a perpendicular bisector. We have angle bisectors. They divide an angle into two congruent angles. Do we see any line in here that's divided an angle into two congruent angles? Then none of those were angle bisectors. A median has a vertex or a corner, and it also has a midpoint. So the two dotted lines go to vertexes, but do they end up at midpoints? Then we don't have a median. And finally, an altitude has a vertex or a corner of the triangle, and it also has a right angle. So here we have a corner of the triangle and a right angle, a corner of the triangle and a right angle. So CE and DF ended up being what? Altitudes. And if you have two altitudes that cross, they cross at what? Orthocenter. So O is the orthocenter. So not only do you have to know how things match up, but you need to know what they cause. So midpoint implies a circumcenter. Angle bisectors, an incenter. Midpoint or medians are the centroid, and altitudes imply an orthocenter. Let me make that altitudes better. So you need to know that. This would be a great thing to study right here for your quiz on Thursday. So you might want to watch the video and pause it and get those points down. So let's take a look at some stuff. The highlighted line, what kind of line is that? Altitude. Why is it an altitude? Corner, right angle. By the way, notice the altitude doesn't have to be inside the triangle. If you have a right triangle, the altitude is the side of a triangle. What's the highlighted line? An altitude. Good. What's the highlighted line? Doesn't go to a corner. Perpendicular bisector. What's the line? Median. Midpoint, corner of a triangle. What's the line? Highlighted line. Angle bisector. All right. What's EG? Perpendicular bisector. What is CH? Angle bisector. What is AG? Median. No perpendicular, so it's the median. What is DB? Altitude. DB is the altitude. What's X? Centroid. These are medians. The median's point of concurrency is the centroid. Hopefully you'll be better at that when you have a chance to study this stuff. All right, here's something interesting. Here I have an equilateral triangle, and this highlighted line is what? It's all of them. It's a perpendicular bisector. It is an altitude. It is an angle bisector, and it's the median. In an isosceles triangle, those four types of lines are all the same line. If it's going from the vertex angle to the base. Here's your homework. We'll go over this Thursday. After we go over the homework Thursday, we'll have a quiz over sections 5.1 through 5.4. Have a great holiday break.